In today's video, we are going to learn what is Docker, how to build a Docker image, and how to run a Docker container on a EC2 instance. If you have still not subscribed to the YouTube channel, then please do the same. I've already created multiple videos on real world AWS projects and will be creating more such videos. In a real world application development, you first need to decide on the programming language or the technical stack that you want to use. Java is the most popular programming language used for application development or web application development, and for creating microservices. Spring Boot is widely used within the industry. So let's say you have decided to use Spring Boot framework for your microservices creation, then you will develop the code, test it on your local machine, and finally you will package it as a jar file. A jar file is nothing but a Java archive, which is a zip file for all of the application code in a single jar package. And for running your application, you need this jar file and the Java runtime. With the combination of both, your application will work correctly. So, as part of the normal cycle, you will develop your code, you will build the jar file, and you will test it. And initially, you will do it on your local machine or your local laptop. Once all of the testing is done, then you will hand it over to your test team. So, to the test team, normally you will give your Java jar file. So this jar file will be shared with your test team, and the test team will deploy it on some environment and start performing the testing. But the test team comes back and says that your application is not working. And you will very strongly argue that I have already verified and tested on my local machine and everything is working correctly. But the tester still insists that the application is not working. So you work along with the test engineer and try to root cause the problem. And you found out that the version of Java that is being installed on the test machine is different. Version 17 Java runtime environment is being installed, and all of your testing has been done on version 8 of JRE. So this is a very common problem where the developer says that it works on my machine, but the application is not working on other environments. Other environments as in integration environment, user acceptance environment, or a prod environment. And the application will not work because the dependency structure is different, right? So Docker solves this problem by using this strategy of packaging the application and all of these dependencies into a single package. And this single package is called as a Docker image or a container image. The beauty of this is your all of the dependencies is present in a single package, and that package or image can be executed on your local machine or it can be executed on any of the environments, and it will behave same or consistent across all of the environments. Docker took the inspiration from the shipping industry. Shipping industry ships a lot of goods, and before the advent of the shipping containers, transferring goods from one location to another was a nightmare. There was no consistent way of transporting items, but with the advent of these containers, the shipping industry benefited a lot. The container became a single unit of storage. Whatever fits inside a container can be easily shipped. Also, all of the required infrastructure, like you see a crane over here, right? So the crane can easily, since the container has a defined specification, the crane can easily shift the container from one location to another location. They can also load these containers onto a ship. Also, the trucks. which transport the container from one place to another, they are designed to carry these container effectively. Also, if you go to the stores like Walmart or Target, then they have these container gates defined in such a way that a shipping truck or a container truck can easily fit into these gates, so that the material can be easily loaded or unloaded. So that's why it is called as containers, because the name come from the shipping containers. So that's the story or theoretical part of the of Docker. From an architecture perspective, there are three main components within Docker. The most important component is the Docker daemon, which is responsible for creating the images, for running the Docker image into containers, to provide the storage to these containers, networking. So all of the technical complicated part is handled by this Docker daemon. To interact with the Docker daemon, you need a Docker client. So the Docker client is called as Docker, and you can issue commands like Docker build, which will build a Docker image. If you want to run a Docker container, then you need to specify a command like Docker run. So to interact with the Docker daemon, you need a client which is called as Docker. The third important component is the Docker registry, also called as Docker hub. So this Docker hub or registry is responsible for storing all of the Docker images. If you push a Docker image to a registry, then it can be easily shared with any team, or you can pull this image in any of your environments. So the main purpose is sharing images across environments or across teams becomes very easy with this registry. So these are the three main components within Docker. So as usual, we will do a hands-on exercise for this particular session. We will create a Spring Boot application. I already have the code present on my GitHub repository. This Spring Boot application will interact with the in-memory database called as H2. We are not using an external database just to reduce the complexity. We will have this application interacting with the H2 database, and we will build a Docker image. We will also deploy it on a EC2 instance, and we will verify whether the application is working correctly. Even if you don't want to do the hands-on, then also please go through these steps so that you get a better understanding. As part of the hands-on, we are going to create a Docker image for a Spring Boot application, and we are going to run that Docker image on a EC2 instance. So for that, you will first need the code for the Spring Boot application. The code is present on my GitHub repository. I will share the link in the description section of the video. In this Spring Boot application, what you need to do is first create a file named as Docker file. This file will contain the steps for creating a Docker image. The main steps are, the first step is you need to specify a from command which specifies the base image for creating our Docker image. Now the base is OpenJDK version 8. So our application is running on Java, and that's where we need this OpenJDK base image. Then we specify the working directory of our application, which is /app. Then for running this Docker image, we need to specify the package or the jar file of our application. This jar file, you will build it as part of your application, and we need to copy this jar file into our Docker image, and the name will be given as app.jar inside the app directory. Then you specify the port on which the application will be running. Lastly, the command to run your Spring Boot application. So this is a very simple Java command, Java minus jar and the name of the jar file. So this steps constitutes the steps for creating your Docker image. The next step will be to install Docker daemon on your machine so that we can build the image. But since everybody has a different environment, somebody will be using Windows, somebody will be using another kind of a system, and the installation steps are little trickier. So the easiest way that I thought is we can go into our AWS UI and AWS account, and from here you can open Cloud Shell, and Cloud Shell will provide us the required configuration to run our Docker container and to build our Docker image. Okay. So open the Cloud Shell in your from your AWS account. It will give you a console, and here we are going to first install Docker. The command to install Docker is this: sudo install Docker. I will copy this and I will run this command inside my Docker, inside my Cloud Shell. Once this command is executed, then we are going to start the Docker daemon using this command: sudo nohub docker d at the rate ampersand. This means that run the Docker daemon in the background. So this is getting executed. It will say install packages. I will say yes. Docker now is now installed in our Cloud Shell. It is complete. Now the next step will be to run this command to start the Docker daemon. This is done. The next step will be to build our Docker image. And for that, we need to clone our GitHub repository. For that, we will use this command git clone, and you can use the command as it is for cloning the Git repository. Let's press enter. It will take a little bit to clone the repository. Then the next command will be to build our Docker image using this command: Docker build minus t web app and dot. Dot means the current directory, and in our current directory there is a Docker file which Docker will use to build the image. Okay, so it is not able to find the Docker file because we have not, we need to go into our directory AWS project Spring Boot, and here it will find the, if you do ls, here it will find the Docker file. I will run the command again, this command. Now it will be able to find the Docker file and it will start building the Docker image. Now, so our Docker image got successfully built. You can run this command sudo docker images to see the list of images. So you will see this image that we have just built, web app. This is the image, Docker image that we have created. The next step will be to push this image to a Docker repository. The famous Docker repository is Docker Hub, but that is a public repository. We will use the AWS Docker repository, which is called as ECR. So Amazon Elastic Container Registry is AWS provided Docker registry. We will create a private registry here. Okay. We can give it a name like web app. This is under our account. This is our account ID, and this is the name that we are giving to our repository. And we will just go ahead and create this repository. Once you create this repository, then it will, if you select this and click on this view push commands, so it will tell you the commands to push the Docker image from your local machine to the ECR repository. Okay, I will copy all of this command together. Okay, and go back to my Cloud Shell and paste this command. So the AWS login command, this is successful, the login succeeded. Then a tag got created with this latest tag. And now we are running the Docker push command to push it to the ECR registry. You will notice that this push operation is happening and it is in progress. Once it is done, then if we go to our ECR repository, if I go to my AWS ECR repository and click here, then we will notice that a image has been visible here. Now let's run this Docker image on a EC2 instance. Before we can do that, we need to create a IAM role so that the AWS EC2 service can access the ECR registry. We will select this. We need to select a policy with this name, Amazon EC2 Container Registry Full Access, and we will see EC2 access to ECR, and let's create this role. Once this is done, let's launch a new EC2 instance, give it a name like Docker on EC2, select the T2 micro, your key pair, select SSH and HTTP port. Then down below, you need to select a IAM instance profile and select the new role that you have created, and let's launch the instance. Once this is done, let's SSH into this instance so that we can run the Docker image. Now we are going to run few commands so that we can install Docker and we can run our Docker image on that EC2 instance. I will copy this set of commands and let's run it here. Press enter. So the commands are mostly to install Docker. The first command is to install Docker. Then the second command is to start the Docker daemon and to show the status. The fourth command is to log in into our ECR registry with the URL of the Docker image that we have just built. So our Docker image name was web app and the version is latest. So this is we are running this Docker command. Now using this command, Docker will automatically download the image from this registry. We don't have to run any separate command. Docker is smart enough to download this image and then run it on port 80. Docker has started successfully here. Docker started service. Then you will see that Docker is now pulling our image from the ECR registry and it is starting our Spring Boot application. To verify that our application is working correctly, we are going to make a get API call using our EC2 instance. So I will select my EC2 instance. I will copy the public IP address, open a new tab, and I will say API v1 employees, which is our API call, and I will say HTTP colon slash slash. So everything is configured correctly, then we will get a empty response. The response is empty because we have not added any employees into our database. But the good thing is we are getting a empty response, which means that our application is working correctly. In the next session, we are going to use ECS to run our Docker image. Thanks for watching and have a good day.